Hello friends, I hope this is our fourth lecture and you are enjoying the sessions and taking interest in the subject. So in the last lecture we have studied the method of law of parallelogram of forces to estimate the resultant, and also we have seen the drawback of that particular method, that the calculations will increase, and that's why I told in the last lecture that today we'll discuss the next method, that is called method of resolution. So today we are going to discuss method of resolution, rectangular components, and also we'll try to practice with the help of some numerical examples. Remember now, in engineering mechanics, we are going to follow certain conventions for the forces. Now, if you look at the first figure, this is O. This is the upward direction, upward. That is positive x-axis, and this is positive y-axis, and this is positive x-axis. So these directions we are going to consider positive, and this is negative x-axis and this is negative y-axis. So these directions we are going to consider negative. So from these two figures, if you understand clearly, all upward forces we are going to consider positive. That means acting in vertical direction, and all horizontal forces acting to the right, I think I should use this hand, to the right, they are positive, rest everything is negative. So remember, vertically upward forces positive, forces to the right they are positive, rest everything is negative. Forces acting to the left they are negative, forces acting downward they are negative. This is simple convention which you will have to remember in throughout engineering mechanics in all chapters. Okay, now let us come to the resolution. So if a force is acting at a point, for example, if you take this is point O, this is a reference system X, Y, this angle is 90-degree total, and force OF, this is a force and this is the magnitude of force, and angle made by this force is angle theta. You will find this force is acting away from origin like this, and that's why if I resolve this force into two components, component along x-axis will be F cos theta, where theta is angle made by this force with x-axis, and component y, this component will be Fy, will be F sin theta. Remember, I have measured the angle with respect to x, and that's why x component is F cos theta and other component is F sin theta. If I measure the angle with respect to y, then this will become cos of theta and this will become sin of theta. But to avoid this confusion, always try to measure the angle with respect to x and take x component cos and y component is sin. If this angle is given 30 degree, then easily you can calculate this angle is 60 degree. So you can write F cos 60, F sin 60. So this force, now I have split into two rectangular components, F cos theta and F sin theta. And remember, the force is acting away from the point, and that's why these components, they are acting away from the point. See, like this and like this. Now take a second case. Force is acting towards the point, towards the origin. Components will remain same. Magnitude of components F cos theta, F sin theta, but the direction of the components will reverse. Okay. This y component is acting towards the point. X component is also acting towards the point. This is the blue color you see. Both the components, they are, so this direction was to the right, now it has become to the left. This direction is upward, now it is downward. So these are the only two cases. Force is acting away from the point and force is acting towards the point. And the conventions which I told, that also will be very clear to you now. You see, this component will be positive, this will be positive, because this is acting to the right, this is acting upwards. These both components will be negative because this is acting to the left and this is acting downwards. So these two figures you should not forget at all, otherwise you cannot solve the numerical examples. It is very clear to you that force is acting away from the points, how the component direction of the components, and the force is acting towards the point, then how the directions we have taken. This fact, it should be very clear to you. You see, now this is single force. So resolution, I have resolved into two components, f cos theta and f sin theta. Now if I club these two components, this f sin theta and f cos theta, the process will be reversed. That is called as a composition. Again you will come to the original system of forces. So resolution and composition, this should be very clear to you. Okay. Then next is how to solve the problems resultant of forces using method of resolution. Now you can take, suppose this is a force F. Okay. Now what I will do, I will resolve this force into two components. Component in x direction is f cos theta, component in y direction is f sin theta. So I will represent x component like this, y component like this, and then with these dotted lines I will prepare a parallelogram. So you know the diagonal of the parallelogram will give you the resultant. This will be the resultant. How you will get the resultant? Because using Pythagoras theorem, magnitude of resultant will be under root of summation of x square. Suppose there are two forces, three forces. You resolve it, take summation of fx square plus summation of fy square. This is fx, that is this square, plus fy square, under root of this, you will get this resultant. And the direction tan of theta, fy, tan, you see direction theta will be tan inverse summation of fy divided by summation of fx. So this is the simple way by which you can calculate the resultant of force systems. See, this is summation of fy, this is summation of fx. This summation I am using because we may get number of forces. Now I have taken a single force, but suppose there are two forces, then we have to resolve those two forces and we will have to calculate total summation of forces along x-axis, total summation of forces along y-axis, and then we will have to find out the resultant as well as the direction. Okay. The next is, let us take the numerical example. You see, determine the resultant of the force system as shown in figure. You see, this is the one hook attached to one plate. 80 Newton force makes an angle of 40 degree with the x-axis. 120 Newton makes an angle 30 degree with this 80 Newton force. So total angle made by this 120 Newton, remember with x-axis is how much? 30 plus 40, 70. And this is force 150 Newton. This angle is 35 degree with the negative x-axis. Remember. So let us resolve these forces. First let us calculate summation of fx. That means if I take 80, the component of this 80, force is acting away from point, and that's why component will be acting towards the positive x-axis like this. This is, so 80 cos 40. Now this again, this is also acting away from point, so component will be acting to the right. 120 cos 70, 40 plus 30, 70, and this force is in, you see here along negative x-axis, so x component will be acting away but along x-axis like this, and that's why 150 cos 35, but the component will be negative because component will be acting to the left. That's why 150 cos 35. Hence Fx will be minus 20.546 Newton, and Fy, you see this force component, vertical component 80 sin 40 acting upwards, then 120 sin 70 acting upwards, and component of this force component, this is acting like this, horizontal is like this, and vertical will be acting like this, vertically upward, and that's why it is positive 150 sin 35. So Fy will be 250.22 Newton, and hence magnitude of R will be under root of Fx square plus Fy square. Under root of square of this plus square of this, you will get resultant 251.042 Newton. Theta will be tan inverse summation of Fy, this divided by Fx. And you see, since we are calculating the angle with respect to x axis only, and that's why ignore this negative sign, even Fx, Fy both, that you can ignore it. Just take the numerical values for estimation of angle theta. You will get angle theta 85.30. Hence the resultant, see, Fx is positive, Fx is negative, Fy is positive, and hence resultant lies in second quadrant. Fx like this, total Fx, and Fy upward like this. That's why the resultant will be somewhere here like this, and angle with x axis will be this much. How much it comes? 85.30 degrees. So this way you can solve the numerical examples. Let us take second this problem. Actually it is second. Two control rods are attached at A. At point A, this is one rod. How much is the force? 120 Newton. To lever AB, and knowing that the force in the left rod F1 is 120 Newton, determine the required force. This F2 we have to calculate in the right hand rod if the resultant R of the forces exerted by the rod on the lever is vertical. So if you read the problem carefully, then only you will understand that when resultant will act vertically upward, in that case summation of Fx must be equal to 0, because theta is what? Tan inverse summation of y by summation of x, and that's why tan 0, and if you take the inverse of tan 0, you will get 90 degree. So find F2 if the resultant is to be vertical. Therefore, when the resultant is to be vertical, it means the sum of x component should be equals to 0, and the sum of y component, that will be equal to resultant. So resultant is vertical, means summation of Fx is equals to 0. So let us take first summation of Fx. So this force you resolve, F2 cos 10, and this you will resolve it to the left, 120 cos 28, and that will be minus. So F2 cos 10 minus F1 cos 28 equal to 0, and hence you will get F2, that is equals to 107.58, and summation of y, that is equals to resultant. So F2 vertical component will be upwards, F2 sin 10 plus this component 120 sin 28, that will be upward, okay, will be equals to R. We know F2, we have calculated 107. Substitute this value here, and you will get 107.58 sin 10 plus 120 sin 28, and hence R will be equals to 75.19 Newton. So this is second example which we have discussed. Let us take, this is the last example. Determine the resultant of the three forces as shown in figure. This is a hook. You will find on this hook, this force is 60 Newton, makes an angle of 25. This is 40 Newton, makes an angle 60 degree with x axis. and this is a 50, makes an angle of 50 degree with y-axis, and hence angle made by this force with x-axis will be 40. Now resolution fx. Let us resolve this 60 degree Newton force first. So 60 cos 25 horizontal to the right. This force also will be having component to the right, 40 cos 60. But this force horizontal component will be to the left, 50 cos 40, that will be minus, and hence total summation of fx will be 36.076 Newton. Similarly Fy, you see this force, if you resolve, vertical component will be upwards 60 sin 25, whereas this force 40 sin 60 component will be downwards, that's why negative. Similarly this force component 50 sin 40 downwards, and that's why negative will be equal to minus 41.42 Newton. So we got fx, we got fy. Substitute these values as usual. You will get r equals to 54.93 Newton, and direction theta, as I told you, ignore the sign positive negative, take numerical values, you will get angle 48.94. Here fx is positive, fy is negative, means this is positive x, this is negative y. So resultant will be in this quadrant. I think it is in fourth quadrant. Here this will be the resultant, and this will be the angle made by the resultant, that is equals to 48.94 Newton. So as I told in the previous lecture, you will find there are only three steps. Step number 1, step number 2, and then calculate r and theta. This is step number 3. So in 3 steps you will get answer for any numerical problem. That is what I told in the last lecture. So I hope you understand, and the concept of method of resolution is very clear to you. And now in this lecture what we have seen the rectangular components, that is considering x and y axis, they have 90 degrees. But if two lines are not at 90 degrees, then how to resolve, and how to get the components, that is called as a skew resolution. That we'll discuss in the next lectures. So I hope you are comfortable and enjoying the sessions. Thank you very much.